Hello, welcome again. We are covering the subject compressible fluid flow for civil services means IFS and Gate Aerospace exam. We are studying the topic Prandtl Meyer expansion waves. So here in the first video we studied some qualitative aspects of the expansion wave, and in the second video we studied some quantitative aspects of the expansion wave and derived a relationship between deflection angle this deflection angle theta 2 and m1 and m2. Okay, so finally we got this in integral form and in terms of m, and the limits of integration are m1 and m2. So now the integration of this is a complicated procedure. So if we are able to find out its integration, we can solve it. So if there its integration is given by Prandtl Meyer function, so that is your mu m. So if we take only m, we do not put the limit, then the integration will be here root gamma plus 1 divided by gamma minus 1 tangent inverse root gamma minus 1 by gamma plus 1 into m square minus 1 minus tangent inverse root m square minus 1. Okay, so this will be integral. So here also again to find out the exact value, we have to uh, follow the complicated procedure. So this value is tabulated. Okay. So for each m this value is tabulated. So this is called Prandtl Meyer function. And so here we can see that for MECH number 1 the value of this mu is 0. For MECH number 1.1, here 0.1180 means in plus 01 is means 1.18. So if 01 is there, then we will take 1.1 here. Okay, if 02 is there, we will take 11.8. So it is 1.180 for 1.180. The value of this mu is 3.074. Okay, so that is your angle. That is the value of mu. Okay, so for each m there is particular value of mu or Prandtl Meyer function. For m is equal to 1, it is 0. So now here our MECH numbers are m1 and m2. So it means this is the integration of this part. So if we put the limit, or we take mu according to m2 and mu according to m1, then their difference will be just deflection angle. Okay. So now we have 16 to 17 equation or 17th equation, that is the most important equation, to solve the numericals, and some special procedure is followed to solve the question. So here suppose deflection angle is known, theta 2 is known, that can be measured or can be calculated. Okay, theta 2 is known. Now we have to calculate m2. Okay, so now initial MECH number is also known. From the initial MECH number we can see the value of mu from this table. Okay. Suppose initial MECH number is 1.2, then the value of this will be 3.5. Okay. And now deflection angle is also known. So if this is known now from the table and this is known, we can calculate this mu m2. So if we can calculate mu m2, then we see from the table for a particular value of mu, for this value of mu, now we know mu m2, so we can see m2 here. Okay, so final MECH number can be found out. So reading this out, now theta 2 is known. First step is mu m1 from the table for a given m1. Find out this. Calculate mu m2 from the equation 17 using the given theta 2 and mu m1. Obtain in step 1. From this and this we can find out this. Okay. So obtain M2 corresponding to mu M2 from step 2. Okay. Now we are able to find out M2. Now we know M1 also. And we know that the expansion is isentropic, so we can use isentropic relation. So if the expansion is isentropic, then the stagnation pressure and stagnation temperature will remain constant. So we can apply the isentropic relation. So T naught by T1 is 1 plus gamma minus 1 by m1 square, gamma minus 1 by 2 m1 square, and T naught by T2 is 1 plus gamma minus 1 by 2 m2 square. Or if we divide these two, then T naught will cancel out, so it will be T1 by T2 will be equal to 1 plus gamma minus 1 by 2 m1 m2 square divided by 1 plus gamma minus 1 by 2 m1 square. Or further, for pressure ratio we can use isentropic relation. This is the isentropic relation. So this is the way to find out M2, T2 and P2 if M1, P1 and T1 are known. So this is the solution of the Prandtl Meyer expansion wave, and will solve one or two numericals based on this concept in the further videos.